We're going to start today by looking at some of our challenges that we have for today, and we're happy that you're here on the show with us. Okay, we're going to go right to our challenges. Our challenge 24, of course, one of our favorite challenges, and we have 4 cards today. Remember that the last card with the 3 dots, that's the hardest one. So we want you to try to work on that one while you're watching the show and call in with the answer to that one. Most people always call in with the answer to card A, which is the easier one. But we really want to stretch ourselves now that it's in the winter time, you've been in school a while. We want to stretch our brains and really think about that. So here we go. Write them down. Card A is 4842. Card B, 8654. Card C, 7245. 5, and card D is 7448. Now remember, you can use this number 2 times because it's listed 2 times on the card. So go ahead and write those down, work on those, and make sure that you call in with the answers to those during the show. Now, we also want you to work on your homework with us. If you have some questions for us today, please call in. And we're going to go to the lines in a little bit. But before then, we're going to look around our studio and we're going to use some of the manipulatives that we have this afternoon to help you with some problems. All right? And the first thing that I brought with me today, I brought some fraction strips, fraction cubes that are going to help us. I know 5th grade, and I know 3rd grade and 4th grade will work with them, but 5th grade is really working on some fractions. So I brought with me my fraction cubes. And I just want to talk to you about 1 whole as compared to the other pieces of some fractions. So of course I have 1 whole, and I also have 1/2. And of course, it's half plus another half makes a whole. But what I really want you to look at today is I really want you to notice some number sense. I want you to look at some of these fraction bars compared to the other ones. So I have a 1/2 compared to 1/3. I also have a 1/4. And I also have a 1/5. Oh, upside down, there we go. And I want you to notice that what happens to each of these pieces. Each of the pieces, if you'll notice, are getting smaller. But I want you to notice the pieces get smaller, but the numbers get bigger. So that's a piece of fraction knowledge that you need to have that will be very helpful for you. Okay, the smaller the denominator, the bigger the piece. The bigger the number, the smaller the piece. Because of course, if I have 1 out of 5 pieces, I would have to cut it into smaller pieces. So here are my 5/5. And we know that's equivalent to 1 whole, okay? But it's 5 smaller pieces than the 1 piece of 1/2. All right, so hopefully that will help you today. We'll get started with some fractions a little bit later. We're going to start working on some calls today. And my co-host is also here today. I didn't introduce her. Good morning, good afternoon, good evening.
Good afternoon. What a lovely, lovely snowy day it is.
It sure is.
I'm Miss Jennerette. Welcome, welcome, welcome.
We're here to help you today, and we did have another delay today.
I know, I couldn't believe it.
I know, but I'm sure you still have some homework for this afternoon.
Yes, because I know math and reading are so important.
They sure are.
So I know you have it. All right, it looks like we do have a caller on the air.
We do. Is it Brian? Hello? Is Brian there? Brian?
Hello?
Miss Cat?
Hi. Hi, Brian. How are you?
Good.
Good. What school are you calling from? What school do you go to?
I forgot the name of the school.
Oh, forgot the name of your school? Okay. All right, what grade are you in?
Third.
Third grade.
Third grade, all right.
Okay. And how can we help you today?
I need help with my homework.
Okay, what problem were you working on?
On the finding the area and the perimeter.
Okay. Of what? What were the dimensions given, or what was the problem that you were given?
The square with 3 inches.
Okay, so it's a square, and each side is 3 inches?
Yeah, but...
And you're supposed to find the what? The area and the perimeter?
Yeah.
Okay. Well, what do you know about perimeter?
That it's wait.
Well, let me help you out today, Brian, okay? Whenever you see the word meter, you know you're going to measure something. All right? Meter is something to do with measuring. And then the other way that I know about perimeter is in the middle of the word perimeter is the word rim. Do you see the word rim?
Huh?
Do you see the word rim? R-I-M in the word perimeter?
The what?
The word rim.
Oh, yes.
Okay. Well, when I see the word rim, I think of a basketball rim, a basketball hoop. All right, and the basketball rim goes all the way around, okay? And that's what we want to do with perimeter is we want to go the whole way around the object, the distance around. So if this side is 3, what's this side?
The side?
Right, what are the lengths of the sides?
With the left is 3.
Uh-huh.
The right is 3.
Okay. And the bottom?
I'm supposed to find out what's the bottom.
Oh, you're supposed to find out what's the bottom? All right, well, you told me that this shape was a square, correct?
Yes.
What do you know about squares? Do you know something special about them?
No.
A square is a very interesting object, okay? It's a really interesting shape. And Brian, did you know that all the sides of a square are the same length? So if this side is 3 and that's 3 and that's 3, what would the bottom one be?
If the bottom one is 6.
If they're all the same length, what's the bottom going to be?
3.
Right, the bottom is going to be 3. Good. Now, if you're supposed to find the perimeter of the square?
Yes, and the area.
All right, well, let's do the perimeter first. Remember, it's like the rim. It's the whole way around the outside, the distance around the outside. So we're going to add up 3 plus 3 plus 3 plus 3. If we add up all of those 3s, do you know how much that is altogether? What is the sum?
12.
Very good. And we need to label it because our perimeter is in inches, so it would be 12 inches. Does that make sense?
Yes.
Okay, now area is a little bit different. Area has a special formula, length times the width. So all we do is look at the length and the width, and we multiply them. So the length was 3 and the width was 3. So if I multiply those, what do I get?
Huh?
What do you get 3 times 3? 3 multiplied by 3.
3 times 3, 8.
Oh, close. 3 times 3 is 9. All right, and when we do area, we're talking about in inches squared. We want square inches. All right, because area means how many squares will fit in the middle.
Okay.
All right? I hope that helped you today, Brian. All right, we're going to take your name and we're going to put it in the treasure chest. Thank you so much for calling today, okay?
Great job, Brian.
All right, have a great day. We're going to move on to our next callers because we have so many.
Yay, I'm so excited. Caller.
Hey.
Is this... Hi there.
Hi.
Caller, are you there?
Hello?
Hi.
Hi.
What's your name?
Michelle.
Hi, Michelle. What school are you from?
Deerfield Run Elementary.
All right, Deerfield Run. And what grade are you in?
5th.
5th grade?
Yeah.
All right. You have a question for us?
Yeah.
Okay. What's your question?
And this question, it says, chickens are sold in 7 8-pound bags. Almonds are sold in 1/4 pound bags. And peanuts are sold in 3 8-pound bags. If you wanted to buy about 1 pound of nuts, which kinds of nuts would you buy? Use benchmark fractions to help you decide.
All right, so you had a lot of information in that problem.
That was a lot.
I heard some bags, right? They have different bags?
Yeah, pound bags.
Different ton bags. Oh, we had a fun tool there. So you started off with 7/8 pounds?
Yeah.
And that was for which animal?
Oh, it's for Pecans are sold.
Okay.
And pecans are sold in 7/8-pound bags.
Okay, so your pecans are 7/8 of a pound. What's
Yeah.
your next nut?
Okay, almonds are sold in 1/4-pound bags.
Okay, 1/4 pound. Okay.
And peanuts are sold in 3/8-pound bags.
3/8 of a pound. All right, and then you wanted to know what again? I heard a pound, right?
If you wanted to buy about 1 pound of nuts, which 2 kinds of nuts would you buy? Use benchmark fractions to help you decide.
Okay, so I see my favorite word in the whole wide world in math, and that's about. Do you know, can you tell me something about that word about?
About means an estimation.
An estimation. So we don't want exactly a pound. We want about a pound, close to a pound, correct?
Yep.
So we have 3 different nuts, a 7/8 pound bag, a 1/4 pound bag, and a 3/8 pound bag. We want to know which bag of nuts is closer to 1 pound. So I'm going to draw a number line. You see my number line?
Yeah.
And I like my benchmark fraction of 1/2. So I hope I eyed it pretty well. So I'm going to put 1/2 right there. Okay?
Uh-huh.
So let's start with our pecans, or pecans, as my husband calls it. Where would 7/8 fall on this number line?
7/8 will be closer to 1.
And how do you know that?
I know that because 7/8 is closer to a pound, because if you add 1 more eighth onto 7/8, you're going to get a 1 whole.
You are going to get 1 whole. I love that reasoning. 7/8 is 1 whole, 1/8 away from 1 whole. So you know what? Let's go ahead and put that right here. But let's change gears for just 1 second, because I want everyone to learn how to use a number line in the benchmark fractions. So we have our number line: 0, 1/2, 1/8. Well, excuse me, 1 whole. What's another name for 1/2?
Another name for a half could be 2/4.
2/4. And how do you know?
I know that because a half is equal to any number that has a half, like 2/4, 4/8, 6, and 5/10.
Good, because our numerator is half of our denominator, right?
Yeah.
So I heard you say 2/4, and then I also heard you say 4/8.
Yeah.
So if this is 4/8, what's this?
Over there would be 5/8.
Excellent, because I partitioned my number line into how many equal parts? I got 1, 2, 3, 4, 5, 6, 7, 8. Right?
Yeah.
You see the 8 parts?
Yep.
So then right after 4/8 is 5/8. I have 6/8. I have 7/8. And what's another name for 1 whole?
Another name for a whole is 8/8.
Very good. And you said 7/8 is 1/8 away from 1 whole. That's
Yeah.
pretty close, isn't it?
Uh-huh.
So where would 1/4 go on this number line?
1/4.
Mm-hmm.
1/4 would be...
Would it be here?
It would be...
Let's count. Oh, go
close
ahead.
to 0.
Close to 0. Here's 4/8. We originally partitioned our number line into 8 equal parts, right?
Yeah.
So if this is 0 and we have 8 parts, what would come right after 0?
Right after 0 would be 1/8.
Very good, 1/8. The 8 shows our equal parts, and that's 1/8. So this would be, this next line after 1/8 would be
2/8.
2/8. Is there another name for 2/8? Let's do this. I'm going to take this line out. I'm going to take this line out, and this one, and this one. So how many equal parts is my line divided into now?
It's now divided into 4 equal parts.
4 equal parts. So now, here's the first partition. So what would this line be?
That line would be 1/4.
Very good. So another name for 2/8 is 1/4. Very good. So let me put my eighths back. Where would 3/8 go?
3/8. 3/8 will go right next to 2/8.
Very good. So on our number line, we have 1/4, we have 3/8, and we have 7/8. And just like you said, 7/8 is closest to 1 whole. So which bag of nuts would you buy if you want about a pound of nuts?
You would get 7/8.
Very good, and that would be the pecans. Excellent, excellent, excellent job. Great job, Michelle. Guess what? Your name goes in our bucket.
I already put it in. All right, thank you so much for calling, Michelle.
Uh-huh.
All right, you have a great day.
You too.
Okay, bye.
Bye.
Another caller. I'm so
I think we
excited.
do. We have so many callers today. We do have another caller. Hello, welcome, caller. Hello.
Can you hear us? Oh, yes. Listen to us through the phone and not the television. Are you there?
Hello. Who is this?
Okay.
Hello.
Hi.
Hello.
Hello.
Who is this?
Edward.
Hi, Edward.
Hi.
Nice to meet you. Welcome to the show.
Hi.
And what school are you from?
Bond Mill Elementary School.
Wonderful. Okay, and what grade are you in?
Exponents.
What grade are you in?
Oh, 5th.
Fifth grade.
Fifth
Okay,
grade.
excellent. You
All
said exponents. Oh my, that sounds kind of tricky. How can we help you?
I want to know how to use exponents with bigger numbers.
With bigger numbers, okay.
Okay.
What problem were you working on?
12 by the power of 10.
The power of 10. Ooh,
That's really big.
that sounds kind of really tricky.
I wanna
So
write it down.
it would look like this, 12 to the 10th power. Does
Yes.
it look like this?
Let me make my 10 a little higher.
Yes.
Okay, great. Now, what do you want to know about the powers, the exponent powers?
How to do them with bigger numbers.
With bigger numbers, okay. So you're saying what this means?
Yeah.
Okay. So 12 to the 10th power, anytime you raise a number to the power, it means take that number and multiply it by itself that many times. So for instance, if we had 12 to the 2nd power, which we call 12 squared, what would that equate to? What's that equal to?
12 to the 2nd power.
Right. What does that mean? What are we going to punch into the calculator, or what are we going to multiply?
12 times 12.
Very good. And 12 times 12 is really a multiplication fact. Do you know what 12 times 12 is?
144.
Oh, very good.
Good.
Now we can keep going. We can do 12 times 12 times 12, and that would be what we call 12 cubed, because it has 3 12s that we're multiplying together. Does that make sense?
Yes.
So when I say 12 to the 10th power, what do you think that means?
Multiply 12 10 times.
That's right. Multiply 12 10 times.
Ooh, losing count.
Now, you could do that. You could put 12 times 12. You could multiply all of that out, or you could use your calculator. And for something like that, I would use a calculator for. Okay, Edward?
Okay.
Now, if you wanted to figure out the answer to that, we could, but really, you just have to know how to do it. It's not really what the answer is right now. You need to know that 12 to the 10th power is 12 times 12 times 12 times 10 times. Does that make sense?
Yes.
Okay. All right. Any other questions that you had about exponents?
No.
Okay,
Oh, wow.
awesome. Well, I'm glad we could clear that up for you.
Yes.
All right. Thank you so much
Yes.
for calling. Did you want to try one of our challenges today?
Yes.
All right. Which one?
D.
Oh, wonderful. I was asking people today to work on D.
It worked. Yay. So,
All right. What are the numbers again? We have 7448. Okay.
7448.
7448.
Let me write that down. All right. Edward,
Yes.
do you
Wait,
have...
7448, I think.
Oh.
2 fours.
Sorry. 7448.
All right.
Do you have a solution?
Yes.
All
7 times 4 is 28.
All right. We did that.
28 minus 8 is 20.
Mm-hmm.
And 20 plus 4 is 24.
Woo! Very good. I am so impressed because, as I said before, a lot of people don't try those super challenging ones. So
Yes.
thank you, Edward, for trying that. And what I'm going to do, put your name in the treasure chest again.
2 times. Yay.
All right. From Edward from Bond Mill. Thanks for calling in, Edward.
You're welcome.
All right. Have a great day.
Okay, bye.
Awesome. So I put his name in one time. I'm going to put his name in another time.
Yes, that is wonderful. So now we have 4 names in the box.
We do have 4 names in the box today.
So
4
I
names.
can write a fraction showing how many Edwards are in the box. There are 2.
Mm-hmm.
4 is our whole.
Mm-hmm.
So that's 2 fourths.
2 fourths are Edward.
2 fourths are Edward.
2 fourths is the same as something else.
I liked what the young lady before Edward said.
I think it was Michelle. Was
Michelle,
it Michelle?
yes. She said that a half, anything equivalent to a half, the numerator is half of the denominator.
Ah, very smart. Very smart.
2 is half of 4. So Edward is equivalent to 1/2.
So he has half of the pieces of paper in that box already.
And half.
Ah. We were talking about that when the show started. I was showing people that a half is a pretty big piece. It's bigger than 1/4.
And that is so unusual because the 4 in the numerator is a bigger number than the 2 in the denominator, of the half. But because the pieces are larger, the smaller denominator determines how big the fraction is when your numerator is 1. So these are called unit fractions. And unit fractions are so fun.
I know, because there's so many patterns to them.
They are.
Half is bigger than 1/4. So the bigger the number, the smaller the piece.
And I liked also how our lovely Michelle used that number line and was able to reason that 7/8 was just 1/8 away from 1 whole. And that goes back to our lovely unit fractions of that eighth.
That's right.
7/8 plus 1/8 equals 8/8, which is a whole. Oh, you know what we could do?
We could do some fractions on a number line.
Oh, but we do have a caller.
But we have a caller. We're taking our time from our callers today. So
Oh, man.
before we do, we'll go back and do that after our caller.
Okay.
I think we have a caller, though. Is it Courtney? Hello?
Hello, caller.
Yes.
Hello.
Hi.
Who is this?
Courtney.
It is Courtney. Wonderful. How are you today?
Good.
Great. Well, welcome to the show. And what school are you calling from?
Bond Mill.
Bond Mill.
Mill.
Oh, that's our second
the
call.
second caller from Bond Mill.
Yeah.
Good job, Bond Mill. All right, Courtney, you have a question?
Yes.
All right, what is your question?
45 divided by 5.
Okay. 45 divided by 5. So, Courtney, I'm going to ask you a question. What is the opposite operation of division?
Multiplication.
Multiplication. I love inverse operations because it can help me undo the other. So I have 45 divided by 5. I could also say 5 times something equals 45. Either one I do, I will come up with the same answer. So, Courtney, which one would you like to see? 45 divided by 5, or do you want to try 5 times something gives me 45?
5 times something using 45.
Okay. So do you know what you can multiply 5 by to get to 45?
I know this. I know this.
You do.
9.
9. And how did you get to 9? What did you do?
I added 5 until I got to 45.
Good. That's a good strategy because with our 5s, a lot of our students, 2s, 5s, 10s, those are pretty good to memorize because you can count by 5s really well. So if 5 times 9 equals 45, guess what 45 divided by 5 is?
9.
It is 9. So we could do it with the inverse operation. We also could have drawn a picture to get to the division problem. But since 5s are a pretty good multiplication fact to have memorized, we can use the inverse operation to find the answer. Okay?
Okay.
All righty. So would you like to try a challenge, Miss Courtney?
Yes.
All right. What challenge would you like to do?
The
We can-
20.
We can put them back up there.
Oh, you
Which
wanna see 'em?
card? We already have one solution to card D.
If you have a different solution, you can try card D again. But we have our card A, card B, card C, and card D.
Card C.
Card C with 7, 2, 4, 5. Are you ready?
Yes.
All right. What is your solution?
7. 7 times 4 equals 7 times 5 equals 14.
Well, 7 times 5 isn't 14. Remember what
7 times 7 plus 5, I mean.
So you want to add them. 7 plus 5?
Yes.
And what's 7 plus 5?
7 plus 5 equals 12.
Okay.
And then 4 divided by 2.
Oh. And what is 4 divided by 2?
2.
Very good. And then what?
12 times 2
Mm-hmm.
equals 24.
Very
All
good.
righty.
Woo! I loved how you persevered and you kept working and you started with the strategy and it didn't seem to work out, so you redid it and you didn't give up. Great job, Courtney.
Great job. I'm going to put your name in the treasure chest again.
2 times. Wonderful, wonderful, wonderful. So this is our time for a break.
I think it is time for a break. We're halfway through the show.
Halfway through the show. Keep those calls coming in. We are here to help you with your homework or any math questions that you may have. So after the break, we will be right back.
Hi, I'm James. I'm from Tilton Elementary School. I'm here today for the email question of the day. Mary needed to place a fence in her yard in order to keep her sheep in. If her yard is a rectangle with a length of 26 feet and a width of 20 feet, how much fencing will she need? Well, let's take a look. So first, I would draw a rectangle to represent her feet. Then I would draw 26 feet at one side and 26 feet on the opposite side. Then I would draw 20 feet at one and another side, and then 20 at the opposite side to represent the fencing. Since we're talking about perimeter, since I have to do perimeter, I have to add all the numbers. 26 plus 26 plus 20 plus 20. 6 plus 6 equals 12, so I'll put the 2 at the bottom and carry the 1. 2 plus 2 plus 2 plus 2 equals 8. Then I'll add the 1. That equals 92 feet. So the fencing of her yard will be 92 feet. That's it for the email question of the day. Stay tuned for some more on Count on Us.
Simple moments are what make every day count.
We don't know what's going on with our daughter. We're worried that she might be drinking or taking something else. My husband saw cans and bottles in the back of a friend's car, but we don't know how to talk to her about it. She's been keeping her life a big secret. I was uncomfortable when a friend asked me how our daughter's doing, so I pretended everything is okay, and realized that now I'm keeping secrets too. My therapist suggested we try Al-Anon family groups. I'm glad we took her advice. It helps to talk with people who understand what you're going through because they've gone through the same thing. Are you troubled by someone's drinking? You might be surprised at what you can learn in an Al-Anon family group from people just like you. Call 1-888-4-AL-ANON or visit alanonfamilygroups.org.
Welcome back. Hope you had your snack.
Yes.
We're ready for the second half of Count on Us. I'm Miss Shirey.
And I am Mrs. Jennerette. We are here to help you with any math problem that you have. I hope you have your book in front of you or your sheet of paper and you are dialing that phone number that is flashing on the bottom of the screen. Call us at 301-772-0080. And I do know this. That they can email questions.
You can.
Yes.
That's right.
And I believe the email address is COU@PGCPS.org.
That's right. You can email us your questions as well.
Yes. Oh, we've had 2 people call in and complete a challenge.
We have. We've had numerous problems today, too, about fractions.
I love fractions.
So we're going to talk about some fractions on a number line.
Oh, yes. That is one of my, well, you know what? I can't say that's my favorite because everything's my favorite when it's mathematics. But I do enjoy a number line.
Number lines. I love number lines, especially with fractions on a number line.
Yes. And my wonderful favorite fraction that sometimes I can eye is my 1/2.
That's right.
That benchmark fraction that can tell you anything and everything.
Anything and everything. 1/2. If you know your fractions, if you know your benchmark fractions, then you can figure out all the other fractions. I told my students today, I don't expect them to know much about this fraction. 2/9.
Yeah.
I don't expect you to know that off the top of your head. But you can figure out what 2/9 means by looking at your benchmark fractions.
And you can figure out if 2/9 is greater than or less than 1/2. Because as our wonderful caller called in earlier, a half any fraction that's equivalent to a half, their numerator is half of the denominator. So 9 isn't an odd number. So half of 9 is another fraction. And you know what? Let's go ahead and do this because we did this with a group of students last time. Half of 9. What's half of 9?
Half of 9? I don't know, because there'd be a leftover.
It would be a leftover. Half of 8 is 4.
That's right. So that's close.
And then half of 10
Is 5.
is 5.
Oh, okay.
And 9 is smack dab in the middle of 8 and 10. And smack dab in the middle of 4 and 5.
It's 4 1/2.
4 1/2.
Ah.
So I'm looking at 2/9. I see that the numerator is 2. Even though 9 is an odd number and a half, I'll have some leftovers. I do know that 2 is a lot less than 4 1/2 because I'm not going to have a fraction that says 4 1/2 over 9. That's not going to happen.
No, so it's definitely going to be less than a half. 2/9 is less than a half then.
So my symbol, 2/9, is less than a half. It would be somewhere over here. It wouldn't be over here because if I go to the left of 1/2, to the right of 1/2, that is greater. To the left is less. So 2/9 is somewhere over here.
Yep. We were talking to my students about almost the same thing, except we started to put more fractions on here. And we said, if you're talking about 2/9, remember that 0 is another name for 0/9. And 1/2 is the same as 9/9. So if you told me that between 4 and 5/9 is going to be here, 0, 1, 2, 3, 4, 5, somewhere in here, 6, 7, 8, 9/9. So it's not exactly, but we were also talking about like estimating.
Yeah, and estimating is wonderful. Another use for our number line with fractions that aren't so unusual like 2/9. Let's see. You know what? Let's compare 3/8 to 4/6.
Okay, that's not that unusual.
I've seen 3/8 before. I've seen 4/6 before. And you know what we used to do back in the day when I was in elementary school and middle school? Actually, we call it junior high school. We had to find the common denominator, and we had to do all these. We called it the wheel of equivalence, actually, a few years ago. Instead of just using plain number sense. I'm just relaxing in my chair. Because one of the things my students always said, they didn't like fractions because it had too many steps.
Too many steps.
So now, number sense, if I can just reason and think about our fractions and the size of the parts, I don't have to do all those steps all the time. So let's look at 3/8 and 4/6. Using my benchmark fraction of a half.
Oh, I know that half. I know that half.
You do?
With the eighths.
What is it?
4/8 would be half.
Oh. So if I look at my benchmark fraction of 1/2 or 4/8, I automatically know that 3/8 would be somewhere around here.
Yep, it's going to be less than a half. Oh, okay.
But then how is that going to help me with 4/6?
But you told me, and so did Michelle, that if the numerator is half of the denominator, it's also a half. So 3/6 is another name for half.
3/6 is another name for a half.
Oh, I get it.
But now I have 4/6.
Oh, so 4/6 is bigger than a half.
Somewhere over here. Let's just put it right there.
Over the rainbow. There we go.
So look at my number line. From my number line, I can tell you that 3/8 is less than 4/6.
And I didn't have to multiply and find common denominators and all that. Now, you might have to for certain problems, but that was a lot quicker.
Yeah, all I had to know was my benchmark fraction of 1/2. And this was another benchmark fraction, like Miss Shirey said. 0.6, 0.8, 6.6. Ooh, that's so sloppy. And 8/8. Those are good benchmark fractions too.
Right, but to solve this one, we definitely, the 0 and the 1 we always start with, but I tell my students as well, you have to know about the half. You have to know about the half.
And halves, everybody knows about halves. I ate a half a pie the other day.
Oh my
It
goodness.
was terrible.
Oh, but it probably was very tasty.
It was delicious. I was so happy about it. Let's just remake this. Let's put our benchmark fractions back. And where that is, 0, 1/2, and 1. Oh, you know what? Let's use a different benchmark fraction.
Okay.
Let's compare 7/8 and 5/6. Now, I know this is 0/8. It's also 0/6. This one is 8/8.
6/6. Ah, okay, that part's easy. We know that.
So, 7/8, I know, like our lovely, was it Michelle? She says 7/8 is 1/8 away from 1 whole.
One jump.
5/6 is 1/6 away from 1 whole. They're both 1 jump away from 1 whole. But now, if I'm 1/8 away from 1, and also 1/6 away from 1 with 5/6, which one is closer to 1 whole?
It would have to be the 7/8.
7/8 is closer to 1 whole. I've got these reversed, don't I?
But you know how I figured that out? I figured that out a really weird way.
Okay, show us.
Because you told me that each one of those is 1 jump away from 1 whole. But I know 7/8 and 1/8 is 1 whole, and 5/6 and 1/6 is 1 whole. But I also know that 1/8 is smaller than 1/6, so the jump that's missing is smaller, so that has to be closer.
Yes.
That's kind of complicated. But I'd rather do it that way than figuring out all those common denominators.
And doing our wheel of equivalence. So we use our 8/8 for our benchmark fraction when we compared these two. 7/8 is greater than 5/6 because the jump is smaller to 1 whole.
Wow. I never thought of it that way. We were working on the brownie problem the other day.
Oh, I love that problem.
Do you know the brownie problem?
We did it maybe it was last year.
Love the brownie problem. The brownie problem has to do with fractions, and it says there are 4 brownies. And since tomorrow's my birthday, I know my friends are going to make me some brownies because they know I love brownies. So if they bring 4 brownies for my birthday, I'm really going to have a problem because there are 7 people that are going to share those brownies.
Oh, wow. Well, how are you going to share 4 brownies if there are 7 people?
Well, I guess 4 people get brownies and 3 people get nothing?
Oh, my gosh.
That wouldn't be being a very nice host,
No,
wouldn't it?
I would
No,
not
I wouldn't
like
be a
that at
nice
all.
hostess for that. So if I had 4 brownies and 7 people, and I gave 4 people some brownies, and the other 3 people came to my party and got no brownies, I think they would cry. They wouldn't like that.
Wish you a happy birthday.
But maybe there's another way we can figure it out with math. I think there is. What happened to my eraser?
Oh, I
there
stole
it is. Here's the eraser. So we were working on the brownie problem in the 5th grade, and we started to draw my brownies. And we were debating on whether that would help us or not. So maybe we can draw the brownies and we can have the callers think about that while we go on to our next.
Ah, there's our 4 brownies.
There's the 4 brownies. So I'm going to leave that like that, and we're going to go on to the next caller, and we'll come back to the brownie problem. I want you to think about that. All right, we have another caller. Hello. Hello.
Hello.
Hello?
Hello. Can you turn down your TV the whole way? Just listen to us through the phone. Watch us on the TV,
Yeah.
but listen to us through the phone, okay?
All right.
Okay, there you are. Hi, welcome to Count on Us. Who is this?
This is Olawashin.
Well, hello.
Washington. Hi.
Welcome to the show. What school are you calling from?
Glenarden Woods Elementary.
Excellent. And what grade are you in?
I'm in 5th grade.
5th grade, okay.
Great. I bet you I know what you're working on.
Huh? I do too. How can we help you today?
I had a question on percentage.
Oh, percentage, okay. Wonderful. All right, what was the question?
It says that Lake Worth near West Palm Beach had about 2,120 acres of mangrove trees 40 years ago.
Okay. Here are the trees.
Only about 13% of the mangrove trees remain. How many acres of mangrove trees remain?
Wow. So we want to find out 13% of this number. Is that what we want to do?
Hello?
Hello?
Hello, are you there?
Yeah.
Good. So we want to find 13% of that number, right?
Yes.
That's right. So if 13% of this number still remains, we need to figure out how many that is. And if you notice, I keep saying the word of with a lot of emphasis. Do you know why?
Why?
Why? Because when you say of, it's usually a clue of multiplication. Sometimes it's a little division, but usually it's multiplication. So what I want to do is I want to somehow multiply these two numbers. But I can't multiply them the way that they look right now. We need to change 13% to look a little bit different. Did your teacher talk to you about this?
Yeah.
Okay, so can you tell me, it's kind of like equivalent fractions we've been talking about all day, but I want to change a percent into a decimal. Do you know what 13% looks like as a decimal?
Yes.
What should it be?
It should be 1300ths or 0.13.
Very good, very good. Now I could also change this into 1300ths like you told me. If you like to use fractions, you could very well do it with the fractions, but when I'm finding a percent of a number, I like to use decimals. It's just easier for me. So what we can do is we have this amount of trees and we want a percentage of that, so I'm going to multiply. Did you do some of these in class?
Yes.
Okay. So all we have to do is multiply 2,120 times 1300ths. Now when we multiply decimals, we can just ignore the decimal until the very end, okay?
All right.
All right, you ready to multiply with me?
Yes.
Okay, here we go. 3 times 0.
0.
3 times 2.
6.
3 times 1.
3.
3 times 2.
6.
Good. Now we're going to multiply. We're going to pretend that that decimal isn't there. We're going to move over, pretend this is like 13 instead of 1300ths, so I need to put a placeholder. 1 times 0.
That's 0.
Good. 1 times 2.
2.
1 times 1.
1.
1 times 2.
2.
Yep, I'm writing very crooked today. Wow, very crooked. Okay, but I think you're getting the idea. Now let's put our parts, all of the parts back together. 0 plus 0.
0.
Okay, let me write it over here. 0. 6 plus 0.
6.
Okay. 3 plus 2.
What?
3 plus 2.
5.
Good. 6 plus 1.
7.
And then 2 plus nothing would be
2.
2. Now, I want to put my decimal back in. How do I do that?
You start from the right and move up and put it in front of 2 numbers.
Okay, so really a whole number always has a decimal. We just never put it there because we don't really need it most of the time. So it starts here. 1, 2. We do go 2 places over. And if we do that, our final answer is 275 and 60 hundredths. Now, I don't know if that answers the problem the way that your teacher wants you to answer it. What was the question in the problem?
The question, it said, Lake Worth near West Palm Beach had about 2,120 acres of mangrove trees 40 years ago. Only about 13% of the mangrove trees remain. How many acres of mangrove trees remain?
Okay. So I don't know if your teacher or the question wants you to be super specific about what percent of the acres. It could be 275 and 60/100ths of an acre are still there, or sometimes the question wants you to kind of estimate. So we could say about, if we estimated this to the nearest whole number, we could say that there are about 276 acres still remaining. Does that make sense?
Yes.
Because I don't really know it. I don't know how specific they want you to be, but this is the exact answer. This is 13% of this number, but if you really wanted to know about how many acres, we could just round it off to 276. All right?
All right.
All right. Thank you so much for calling. I'm going to put your name into the treasure chest.
It is in there. Would you like to try a challenge?
Yes, I would.
All right. Do you want to see the cards again, or do you know which challenge you want to do?
Could I see the cards one more time?
You sure can. Here you go. We have 4. Someone called in for card C and D, so you can come up with a different solution. But then we also have card A with 4248, card B with 8654, card C with 7245, and card D with 7448. So which card would you like to try?
I think I would try card D.
Card D, all right.
Okay.
Someone called earlier, so make sure you do a different, have a different solution. 7448. All right, what do you want to do first with those numbers?
7 times 4
Okay. And what is that?
would equal 28.
Okay.
28 minus 8 would equal 20. And the 20 plus 4 would equal 24.
Okay.
I think that is a different one.
Yay!
All right.
Great job. So you know what
Excellent
that
job.
means? You go in the treasure chest 2 times. We have a lot of people in there 2 times.
I know, we
You guys
do.
are doing a wonderful job with the 24 challenge. Great job. And, oh, the brownie problem.
Uh-huh.
Let's put that back
There's
up.
lots of different ways to do the brownie problem. There are lots of different scenarios, I should say, with the brownie problem. But the scenario I gave you is, of course, tomorrow there will be 4 brownies and 7 people at my birthday party. And here it is. Here are the 4 brownies. And we have 7 people coming to my party.
I'm going to eat all 4.
No, we have to be fair to everybody at the party. That's being a good hostess.
Oh, man. Okay.
Can we think of a different way to solve this problem?
Well, since I don't have enough whole brownies for each person, maybe I can cut or partition these brownies so that everyone at least gets something.
Okay. Well, what if we cut it in half?
Okay. So, now that I see halves, I see that I have
Person 1 could get that. Person 2, person 3, person 4, person 5, person 6, person 7, person 1.
Yes, I'm person 1, so that means I have this piece and this piece. I have a half and a half, so really I have a whole.
No, you're not getting a whole brownie at my party. We have to think differently.
Oh, man. All right.
Think differently.
So we cut each brownie in half,
That didn't work.
and it wasn't fair.
Nope.
So let's see if we cut it into. Do we want to cut it into thirds?
We could cut it into thirds. We could see what happens if we cut the brownies into thirds.
Okay.
There we go. There's thirds.
Definitely more parts.
1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5.
Oh. 2 people
Aren't going to get the same amount.
would not like that. So,
Didn't work.
didn't work when I cut it into halves. Didn't work until when I cut it into thirds.
Well, how many people are coming to the party?
7 people are coming.
7 people. Well, what if we cut them into sevenths?
Okay. If we cut it into sevenths, I wonder if we would all get the same.
3, 4, 5, 6. It's not very good picture, but I did try to cut them into 7 pieces.
Well, and we're going to just say that they're the same.
Okay.
And they're the same size, so no one will get upset.
So this person gets piece 1, 2, 3, 4, 5, 6, 7.
So if I cut these into sevenths, 1, 2, 3, 4, 5, 6, 7. So then 1, 2, 3, 4, 5, 6, 7. Oh, now it seems to be a little bit fair. Not even a little bit fair, real fair. 1, 2, 3. This is so hard to do. This is why.
I guess
1,
I should have
2,
had a
3,
different
4,
number of
5,
people come
6,
to my
7.
party.
But you know what? I was thinking you're going to do something else. It would still, though, and you know what? It'll be so fun to see that it still comes out the same. So now, everyone has how much?
Well, I'm coming to the party with 6 other people. So if I'm person number 1, because it's my birthday, I get everything. So I'm really getting 1/7 of this brownie, and 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 so is everybody else.
So if I have a 7th and a 7th and a 7th and a 7th, and I'm person 2, I am going to get 4/7 of a brownie.
Oh, so we could share it. If we cut each brownie into 7 pieces, everybody would get 4/7 of the brownie.
You know what I thought you were going to do? And I wonder if we do it a different way, will we still end up with 4/7?
Okay, let's try a different way.
I don't know if it'll work, but
Okay.
we have 3 minutes
All right.
to see.
There's so many brownie problems. That's just one that we did.
And I
do a
love it.
bunch of them.
Because this is what I thought was going to happen. So when we originally cut it in half, we ended up with 8 halves. So one person had a half, you get a half, you get a card, you get a card. But then we had this extra piece. So instead of, really we should give it to the birthday girl, but she is such a wonderful hostess.
No, everyone must share
She
it.
wants everyone to have the same. We can take this half and cut that half into, let's see, 1, 2, 3, 4, 5, 6, 7.
Oh, so if I cut the half into 7 pieces, half, well, 1/7 of that half.
And actually, these would be 14ths.
That's right.
Because the whole brownie would be into 14 pieces. I just didn't cut this part.
Right, so really you took 1/7 of 1/2, and if I multiply that out, I would get 1/14.
Yes.
So each of those little pieces is 1/14 of the brownie.
Oh, I even did this too. I love this. 1/2 divided by 7.
Oh, stop. What?
So now 1, 2, 3, 4, 5, 6, 7.
Oh,
So
I
let's
get it.
See what the birthday girl gets. She gets this piece, which is a half,
Uh-huh.
and then she gets this piece, which is a 14th.
Uh-huh.
So 1/2 plus 1/14. I know that 1/2, half of 14 is 7. And I know I got to add like denominators. So if I take 7/14 plus 1/14.
I know, we're not getting the same answer, and we should have.
Wow, we should have. Now, that's because I did something. Yeah, no.
1/14.
Yes. 8/14.
Uh-huh.
And I know 8/14 can be simplified because it's two even numbers.
I get it. Then you have to simplify, and we'd still get
Because 8/14 is equivalent.
to 4/7. We'd still get 4/7 of a brownie. I'd rather do it this way because you only have to cut big pieces.
But then it's so
Excellent.
small with a knife, little 14ths of a piece. But look at that.
All right, we got to choose a name.
Oh,
We
yes,
have to choose a
yes, yes, yes,
name.
yes,
Let's
yes,
choose a
yes.
name. Choose a name. Who's the winner?
And the winner is...
The winner is...
La, 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 la. Edward
Oh,
from Bond
Edward!
Mill.
Excellent,
Woo!
excellent job. Well, thank you so much for tuning in with us today. Stay tuned because the next half is coming up from 5 to 6 o'clock. It has been our pleasure to help you today. And remember, you can always count on us.
Hello, my name is Mrs. Sun, and I'm here with today's mini lesson on area. Very often people learn about perimeter and area at the same time, so I want to talk to you about what area is and the difference between the two. Our objective today is to apply measurement concepts in order to determine area. Area is the number of square units inside a shape. So we are looking at the inside of a shape. So very often you're going to look for keywords in word problems. Sometimes people are talking about finding carpet for a room or tile for a floor. Look for those keywords where the word problem is talking about covering the inside of a shape, because often they won't say find the area. They will say how much carpet is needed, or how much tile is needed, or how much paper to cover. That would be another keyword, a bulletin board. So look for those keywords, and we're going to talk about how to find area in a moment. There are a few different ways. Let's take a look at word problem number 1. Melanie wants new carpeting. There we go. There's that keyword for her family room. Her family room is 8 feet by 4 feet. How much carpeting does she need to cover the room? Anytime there's a word problem and you don't see the shape, go ahead and draw that shape. So I'm going to draw a rectangle here. It's not going to be the prettiest rectangle, but it's going to work. And we're going to label that. We know it is 8 feet by 4 feet. Now, in order to find the square units inside, we often multiply to find the area, and that will work, but I want to explain why that works. When we are multiplying to find the area, 8 times 4, what we're doing is 8 groups of 4. So what we're really doing is we're really building an array inside of this shape. So we would break this up into 8 groups. Okay, that's 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They're not equal, but pretend they are. And then here we would have 4 groups. So what we are doing when we are multiplying is we are building rows and columns of equal groups to build an array for 8 times 4. So if we counted that out, we would know that that would equal 32 square units. Since we know it's feet, that's 32 square feet. Anytime we're talking about area, we want to talk about the square units because we are building those square units inside of a shape when we multiply. So to find the area of a rectangle or a square, I want you to multiply, but the reason is you are building that array inside. If you are finding perimeter, I want to talk real quickly about the difference. Perimeter would be the distance around. So it would be 8 plus 4 plus another 8 over here plus another 4 over there. But that's another mini lesson for another day. Let's take a look at one other problem. I really like this problem. This is from mdk12.org. Nathan divided his rectangular garden into 8 sections that are the same size and shape. What is the area of the whole shape? So this side right here says 4 feet, and this says 7 feet. So there are a few different things we could do. If we want to multiply length times width, we could find the length and the width of the whole thing. If this section is 4 feet, this section is 4 feet, so this whole thing would be 8 feet. If this is 7, and we know that this is a rectangle, then this is 7, and this is 7. So this whole thing would be 14 feet. So we found the whole length and the whole width by using what we know about these rectangles right here. So we could multiply the length times the width, 14 times 8. 8 times 4 is 32. 8 times 1 is 8. Plus 3 more is 11. So it would be 112, remember, square feet. Okay? Now we could also find the area of this rectangle right here. by doing this rectangle right here would be 4 times 7, because that's length times width, which is 28, and then 4 of these exact rectangles. So 28 times 4 would be 8, and 3 more would get you the same answer, okay, square feet. But I like to find the length and the width of the whole rectangle. Otherwise, be careful, because 7 times 4, 28, was the area of this whole rectangle, and that whole rectangle happens 4 times. So be very careful of word problems, but remember, for rectangles and square, length times width. If you're not sure, you can always remember ma and pa, multiply area, perimeter, add. That will help you remember the difference. So, my name is Mrs. Sun. That was today's mini lesson on area, and I hope you have a wonderful day.
Simple moments are what make every day count.
A healthy diet and plenty of exercise are keys to success, both on and off the ice. Teaching kids how to eat right will give them the fuel they need to be at their very best.
Growing bodies need lots of fruits and vegetables, whole grains, lean protein, and low-fat dairy to be healthy and strong. A registered dietitian can work with your family to help you create nutritious meals you will love.
And don't forget to exercise for at least 60 minutes every day. Visit kidseatright.org for more information.
There to solve math?
Me! Your live homework help starts now. Welcome to Count on Us.
What is the length from the entrance to the giant wheel? All right, so let's add 3 here and see what happens. First, measure first. I need you to double check yourself. So the second equation for solving perimeter is?
2 times length plus 2 times width.
Hi, and welcome back to the second half of Count on Us. I'm Miss McCants.
And I'm Miss Twitty.
And we are happy to be here for the second hour. Let's talk about the ways that they can get in contact with us.
Okay, you can always call us at 301-772-0080.
And we also have an email corner, which is COU@PGCPS.org. And on Comcast, we are on channel
96
and Verizon 38.
And you can always go to the PGCPS website and look down for the webcast.
Okay, so now let's get to our 24 challenge. Our 24 challenge today. We'll put the card up there. All right, let me move this up. All right, so everyone should be able to see that. Card A is 2484.
Card B is 4865.
And card C is 5724.
And card D is 8742. 8744. So make sure you write those numbers down.
And remember, with the 24 challenge, you have to use a combination of addition, subtraction, multiplication, and division to come up with the number 24. And you have to use the 4s twice. If you see a number twice on the card, you have to use it twice in your solution. Okay?
Okay, it looks like we have a caller on the line, so we'll go ahead and take our first caller.
Okay.
Okay, good evening.
Welcome to Count on Us.
Hi.
Hi. What's your name?
Oluwaseun.
Hey, Oluwaseun. I think I remember you calling in the first show. So welcome back to the second show, and thank you for hanging on and waiting for us to get started. What's your question?
I had another question on percentage.
Okay.
It says the tail of the spider monkey is 64% of its length, and that the 5 inches. So what is the length of its tail?
Okay, so the spider monkey is 55 inches long,
The tail.
and 64% of the 55 inches is the tail.
Okay.
Is that right?
Yes.
And we want to know how many inches
Is
is the tail.
Yes.
Okay, we're in harmony tonight.
Okay, so I wrote down the information, the important part of the information. I wrote down 64% of 55 inches.
Yes.
Okay, so what do you think we need to do first with the percent? Let's start with that. Because we know that this is part of a number. This is not a whole number. 55 is the whole number.
The percent, you have to change it to a decimal or a fraction.
Okay, so which one do you want to work with? Which one do you think would be easier?
A decimal.
Okay, a decimal. So how would we change 64% to a decimal? We know that this is going to be 64 per 100. So I'm going to rewrite that down here. 64 per 100, right? Or 64 hundredths. So if I wrote that as a decimal, what would that look like?
It would be 0.64.
Okay, 0.64. Okay, and of means what?
And that means that is the decimal point.
Okay, you said and, but I'm talking about of. What does of mean?
Oh, of
Mm-hmm.
means part of.
Part of, or what operation do you think we should use? Multiplication, division. The word of is a signal for an operation word.
Multiplication.
Okay, we're going to multiply. So of means to multiply. So 64 hundredths times
55 inches.
55 inches. And while we were talking, my partner here came up with another way that we could show this using our fractions. Okay, so we have two different ways that we can show this. We can show this as 64 hundredths as a decimal, and then we're also going to write 64 hundredths as a ratio. Well, yeah, a ratio. Okay, and we're going to solve for the missing number. Okay?
Okay.
All right, so 64 hundredths times 55 inches. We're going to write down 55 first. I like to put my decimals at the bottom. Is that okay?
Yeah.
And then we're going to multiply that together. You ready?
Yeah.
All right, so what's 5 times 4?
20. You're going to put the 0 down and carry the 2.
Okay.
So then, again, 5 times 4 would be 20, plus 2 would be 22.
Okay. We're good so far.
Next, we have the placeholder.
Mm-hmm.
And we're going to put that below the first 0 up there. And next, we're going to multiply the 5 by the 6
Mm-hmm.
to get 30.
Mm-hmm.
So we're going to put the 0 and carry the 3.
Mm-hmm.
So then there'll be 5 times 6 again.
That's right.
And plus the 3 will be 33. So we're going to write down 33.
Mm-hmm.
Then we can add them up.
All right, so let's do it. 0 plus 0 is?
0.
Mm-hmm. 2 plus 0 is?
2.
Mm-hmm. 2 plus 3?
5.
And we have 3 by itself. We're just going to bring it down, right?
Yeah.
Okay. So we're not finished, are we?
No.
No, we have to do something with that decimal. So we're going to go back up here and do what?
We're going to take the decimal, and from the far right, we're going to put the decimal 2 spaces to the left.
Okay.
Since there are 2 numbers behind the decimal point.
Okay, so we're going to count the decimal places up here. So we have 2 decimal places, and you're saying start over here, and we're going to move the decimal over 2 places to the left?
Yes.
Okay, so now our final answer is going to be 35 and
2/10.
2/10. Okay, so inches, we need our units because we're still talking about length, right?
Yeah.
Okay, so our answer is 35 and 2/10 inches for the tail.
Percent.
So that would be 35 and 2/10 inches, or 35.2 inches.
Mm-hmm.
What was your question again? You want
Yeah.
to find, you're right, you want to find how many inches
The
the
tail,
tail
is for the
Yes.
total monkey.
If it's 64%, yes.
Okay, so Miss Twitty, Miss Twitty has come up with, remember we showed you the other way, right?
Yeah.
So she worked it out the other way for you. So did you want to walk him through how you came up with this one?
So I multiplied 64 times 55. So I multiplied the denominator and the numerator, and I got 3,520. Then I divided by 100, and that gave me 35 and 2/10 inches. Okay?
Okay.
All right, so we're going to go ahead and put your name in the treasure chest. Do you want to try one of the challenges?
Yeah, I wanted to try card C.
Card C. All right, so let me write down the numbers for that. 7, 2, 4, and 5. 7, 2, 4, and 5. Are you ready?
Yes.
Okay, I'm ready when you are.
So the 5 plus the 7
5
would be
plus
12.
7
okay.
equals 12.
And then the 12 times the 4 would be 48. And then the 48 divided by 2 would be 24.
Excellent job.
Very nice job.
Yeah.
Woo.
So you
All
are
right.
awesome. You solved that like a pro.
So we're going to go ahead and put your name in the treasure chest right now, okay?
All right.
All right, so you're in there twice. Keep watching until the end of the show, and if you need any more help with your homework, feel free to give us a call, okay?
All right.
Okay. That was great. I like percents of a number.
Okay.
All right. So now we don't have any more callers right now, but the number is 301-772-0080. Give us a call. We know that you're watching. It's cold outside. Your mom and dad are not letting you outside in this weather. So give us a call because you have homework. You had a 2-hour delay today. But while we're waiting for your calls, we are going to go over some ratios and proportions word problems. We know that 6th grade is working on that right now. That's in their unit. And we are working with fractions, which are lending themselves to ratios with equivalent fractions. So here's a word problem. Are you ready?
I'm ready.
All right. So it says $3.99 for a 16-ounce bag of candy would be a better buy, or...
Oh, wait, I have to keep this here.
Or would $2.99 for a 12-ounce bag of candy be a better buy? So it's $3.99 for a 16-ounce bag. Are you writing with your left hand?
I am.
Oh, okay. Wow, you're awesome. Or $2.99 for a 12-ounce bag.
Oh, my goodness.
Which would be the better buy?
Okay. Ooh, this is a hard one.
Okay, so what do you think we need to do to come up with the answer for this?
Well, I think first, maybe we need to find out how much per ounce.
Okay, and per ounce means we're talking about 1 ounce. How
For
much?
each ounce.
How much it would be for each ounce. So we need to get our unit, or if we wrote it as this one, $3.99 over 16 ounces, we need to have 1 as our denominator.
Yes.
Okay, so the same thing for this one?
Yes, the same thing for that one.
So $2.99 over 12 ounces would be equal to 1 ounce, because you said per ounce.
Yes.
Okay, so
now, based on the last call, I think I just have to multiply.
Multiply. But what do we do from here to here?
I went from 16 ounces to 1 ounce. So I went from a larger number to a smaller number.
So that means we will either have to do
subtraction or division. Oh. So I think we should divide.
Okay, we're going to divide. I think that would be an easier way to.
I do too.
Okay, so could we round it first?
Round it?
$3.99. Could we round $3.99?
$3.99. Well, that sounds like it's very close to $4.
That's right.
Okay.
Okay, so we're going to keep that in mind, but I think we have a caller waiting for us. So what we're going to do is put this back over. You're going to hold on to that one?
I'm going to hold on to this one.
And caller, are you there? Hello?
Hi, good evening. Welcome to Count on Us.
Hi.
How are you?
Good.
What's your name?
Sanaya.
Sanaya. That's a pretty name. What school are you calling from, Sanaya?
Glenarden Woods.
Glenarden Woods. What grade are you in?
I'm in 4th grade.
You're in the 4th grade. Who's your teacher at Glenarden?
Miss Harden.
Miss Harden? You said Miss Harden?
Yes.
Okay, so can you let her know that we said hello from Count on Us, and thank you for having you all call us.
Okay.
Okay, so what's your question?
It says in 7 through 11, draw a picture to find each quotient. I'm on number 10, and I have to draw a picture, and the question is 4 divided by 2/3.
Okay.
4. You said divided by 2/3?
You know I could write for you.
You don't like my writing?
Not on the left hand.
Okay, is this what your problem looks like? Okay, you said yes. I'm going to erase that so my partner can make sure it's nice. Okay, so 4 divided by 2/3. That's your problem?
Yes.
All right, what do you think we should do?
I think I'm supposed to multiply it.
Oh, okay, you're correct. There's a step where we have to multiply, but what do you think we should do with this whole number first?
Convert it to a fraction.
Oh, I like that word, convert it to a fraction. How do we convert it to a fraction?
Put the 4 over 1.
Very nice job. Okay, and now what do we do?
And then you replace the division sign with the multiplication sign.
Okay, I can just replace it.
And then you put the 3 over the 2 and the 2 under the 3.
Very good job. So my 3 is my numerator and my 2 now becomes my denominator. Do you know what that's called?
Reciprocal.
Oh, right. You take the reciprocal. Very nice job. Okay, so what's next?
You're supposed to multiply 4 times 3, and then you get 12. And then you multiply the 1 times 2, and you get 2.
Okay. Okay, and then what's my last step? That 12 halves. Is there something we can do with that fraction?
You're supposed to simplify it.
Oh, how do I simplify it?
Well, 2 can go into 12 6 times.
Uh-huh.
And 2 can go into itself once.
Okay, very nice job. 2 can go into 12 6 times, and 2 can go into itself once. So 12 halves simplified equals how many?
6.
6. Okay, very nice job, Shania.
There is one more thing that I would like to talk to you about, Sanaya, and I'm not sure if your teacher told you this, but we could also model this with 4 holes, right?
Mm-hmm.
And we could break this up into thirds, okay? So this one right here is supposed to be representing 1 hole, okay? So what I'm going to do is just take those out so I can divide my holes into thirds.
Okay.
Okay, so what we're going to do now is we're going to shade in the 2/3. Does that make sense?
Yes.
Okay, so here's 1/3 that I'm going to shade in. Hopefully this marker will work for me. Can you see that?
Yes.
Thank you. So now that's 2/3 shaded in. Another 2/3. So now we're going to count the thirds up and see how many we have, okay, that are shaded. So 1, 2, 3 thirds, that's 1 hole. 1, 2, 3, that's how many?
Wait, what did you say?
We're counting the thirds. Yes.
So this part that's green, we had 3/3, so that's 1 hole that's shaded. And then we're going to shade another 3, so that would be 2 holes that are shaded. Do you see that?
Mm-hmm.
That doesn't make sense to me. We're taking it and dividing it into thirds. We're going to work on this, and then we're going to come back to it, because I want to make sure that I model this for you, because they may ask you to do something similar to this on a test for park, and we need to make sure that this comes out evenly, just the way we had the 6 hole. It should come out the same way when we divide those 4 holes into 2/3. Does that make sense?
My question is, how do you draw it?
2, 3, 4. That's what we're going to do. We're going to actually show you the model, because I thought I heard you ask, how do we model 4 holes divided into 2/3? Okay?
Yes.
So stick around until after our commercial break, and we should have the answer ready for you when you come back, okay?
Okay.
All right. Thank you.
You're welcome.
And we're going to go ahead and take our break now, and we'll see you in a few minutes.
My name is Shayla Tucker from Stephen Decatur Middle School from 6th grade. I'm here with your email coin for today. Here's our problem. Judy has 8 candy bars. She wants to give 1/3 of a candy bar to everyone in her class. Does she have enough for all 24 students? We already have our diagram divided into 3 pieces, so now we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have 24 pieces. And now for our numerical expression, we have the total of candy bars, which is 8, divided by the parts that are shared, which is 1/3. So we make our fraction. which is 8 divided by 1/3. Now we have to find the reciprocal, and we have to change 8 to 8 over 1 because we have to make this a fraction, times 3 over 1 because that's our reciprocal, which equals 8 times 3, which is 24, and 1 times 1 is 1. So our solution is she has enough for all 24 students to have a piece. My name is Shayla from Stephen Decatur Middle School with our email corner for today. See you next time.
Hey, where'd I help this guy?
Help Ricky Rubio save a life at heartrescuenow.com.
Hi, I'm Lourdes Stefan, host of Univision's Sal y Pimienta. Cancer treatment can steal your beauty, confidence, and self-esteem. It causes changes in your skin and your hair. But Look Good, Feel Better can help. Visit lookgoodfeelbetter.org to find a workshop in your area. Let us help you feel like you again.
Welcome back to Count on Us. Miss McCann is over here continuing to work on our last problem.
Okay.
So she's going to go ahead and finish our model. We're here for about the next 25 minutes to help you with your homework. So if you have any or you need any help with your homework, feel free to call us at 301-772-0080. Again, that's 301-772-0080. Hopefully, if you're watching us, you're either on Comcast Channel 96 or Verizon Channel 38, and you can find us on PGCPS website. Go down to the bottom and you'll see the webcast. Okay, Miss McCann, did you have our model for us?
I am ready.
All
Sanaya
right.
called with the problem, so I wanted to make sure that I clarified. She needed a model of how we need to break this up. Okay, so Sanaya, this is what we did. We came up with our four hole. Remember, we talked about that, and then we divided each hole into thirds. I shaded in or color coded the 2/3. So here's a set of 2/3 here. That's 1. A set here. That's 2, 3, 4, 5, and 6. We have 6 2/3 parts, if that makes sense. So we have 6 2/3 parts of the 4 hole. Okay, so I try to put the colors together to show you the 2/3 of the 4 whole numbers. And you have 6 of them total. Okay, so there's your model. I'll leave it up there for a few more minutes so you can see what you need to do to color in those parts. And if you need to, just label them 2/3. Okay? All right. Thank you so much, Miss Twitty.
All right. I think we're ready for our next caller.
Okay. What caller? Who is this? Caller, are you there?
Hello?
Hello.
Hi. Good evening.
Hi.
Is this Star?
Yes.
Hi, Star. What grade are you in?
7.
Oh, never mind.
All right. So you have a problem for us today?
I'm sorry?
What's your problem?
I'm working on linear functions.
Oh, wait a minute, Star. What school do you go to?
I'm sorry?
What school do you go to? What school
Thomas Pullen Creative Performing Arts.
Oh, Thomas Pullen Creative and Performing Arts.
I'm impressed already.
Who is your math teacher at Thomas Pullen?
I'm sorry?
Who is your math teacher?
Mr. Malone.
Mr. Malone. Okay, so you make sure you tell Mr. Malone tomorrow that Count on Us said hello.
Okay.
Okay, so what's your math problem on linear functions?
Okay, so I get confused because,
Me too.
like, it's really hard. Okay.
I know.
So it's like an X and Y chart, And then
you got a function table. You got a function table?
I'm sorry?
You have a function table.
Yeah, the function table, it has 03152739.
Okay.
So I know.
Okay, wait a minute, Star. You're going to have to say a little bit slower, and we heard some noise or something in the background. So
Okay,
so we need to hear you, and you're going to have to say it a little slower so we can write down what you have, okay?
Okay.
All right, so you have X and Y function table, and you have 0, 3.
No, for under X, I have 0, 1, 2, and 3.
Okay, I'm with you.
Okay.
And for Y, you have what?
3, 5, 7, and 9.
3, 5, 7, and 9. Okay.
Okay, Star, so what's your question?
Oh, I'm just confused. Like, I don't really...
So is there a question?
Okay, they just gave you a function table. You don't have something that you're supposed to identify the rule or anything like that?
Like, I have to find the y-intercept.
Okay. So, do you know the rule for slope? M
equals mx plus b?
Okay. So,
Wait, no, y equals mx plus
okay,
b.
y equals mx plus b. All right. And you need to find the y-intercept?
I need to plug in the numbers for m and b.
Okay. So the number for m is going to be your x value.
Yes.
Yes. And the number for b is going to be your y value.
Okay.
Okay?
Okay.
So now if you plot these points, we have graph paper, don't we?
I'm sorry?
I'm trying to get some graph paper for you so I can model for you what's going on. So if you have these points, yeah.
Mhm.
So you said 0, 3, 1, 2, 3, and you said 0, 3, 5, 7, and 9, right?
Yes.
Okay, so if I'm plotting this starting at the origin, I'm going to go up 3. 1, 2, 3, right?
Oh, wait, I kind of don't understand it, like on the graph thing. I mean, I do, but I just do it better when I look at it the way that you write it out, the algebraic way.
Okay, but I'm going to show you this way because you said you needed to find the y-intercept.
Okay.
Okay, so this is why I'm showing it to you this way. So I'm going to start at the origin and I'm going to go up 1, 2, 3, right? I'm going to tell you right now, if you're looking at it just from the function table, this is your y-intercept. 0, 3 is your y-intercept because it did not leave off of the y-axis. Do you see that it didn't go over on the x anywhere? So whenever you have 0 in your x column and you have a number in your y column, that's going to give you your y-intercept because it's crossing over the y-axis.
Okay.
That makes sense?
Yes.
So remember, every time you see a 0 in the x value for your function table, you're going to get the y-axis, the y-intercept in your y column.
Okay.
Does that make sense? But I can go ahead and plot the rest of it for you, but you really don't need it now that we know this is going to be your y-intercept. This is where it's going to cross the y-axis. Okay?
So start. If this was 0 and 5, what would your y-intercept be?
If my y-intercept.
It's wherever the point crosses over the y-axis. So where would it cross the y-axis if we had 0, 5 here?
That's a good question. Okay.
Okay, so listen to her explanation again.
Okay, so listen. If I start over and I have x and a y, you with me? Can you see it on the screen?
Yes.
Okay, so if I have 0 here and 5 here, automatically I don't have to do any math. I don't have to do anything with that equation, y equals mx plus b. I don't have to do any of that because right here it's telling me that my y-intercept is going to be 5. This is where it crosses over because there's no value here for the x. I'm not going to go on my coordinate plane and move on the x-axis. It's going to just slide right up on the y, and that is going to be my y-intercept because it crosses over the y-axis. Make sense?
Yes.
So I'm going to give you another one. If I have 0, 9, what's my y-intercept?
9.
Why?
Because it's on the y. It's on the y line.
Because
it's on. Yeah.
Because because the x doesn't move off of the origin, and all we have to do now is either go up or down to find the y. So if I have 0, -2, what's my y-intercept?
-2.
-2. Does that make sense?
Yes.
Because that's where it's going to cross over the y axis. And Miss Twitty just drew in the points that you gave us for the first function table. She plotted it on the coordinate plane so you can see that this line, once you put your points down, you draw your line, it crosses over the y-intercept, the y-axis. And you know what intercept means, right?
Yes.
Okay, so this is where it crosses, right in that spot.
So, Star, what does intercept mean?
I know what it is, but I don't really know how to explain it.
Okay.
But I still had a question about the y equals mx plus b. I still need to
Okay, wait a
find
minute,
out.
Star. Hold on. Let's make sure that we understand what this word intercept means if you're looking for the y-intercept.
Okay, and the way I used to like to teach my 7th graders, it's just like when we're watching football and they get an interception. Do you watch football?
I'm sorry?
Do you watch? I know you're a girl and everything, but I'm not sure if you're into football.
Yeah, I do.
You do watch football?
Yeah.
So what is an interception?
It's like, no, I can't really explain it, but I know what you mean. I know what you mean.
Okay, so this is how someone intercepts the ball during during an NFL game. That person from the other team has come in and caught the ball when they shouldn't have, because it was a line. The quarterback throws the ball in a line, and if, let's say we're the Redskins and we're playing the Ravens, if the Ravens sees the quarterback throwing it to anybody on the team, then one of the Ravens players can come in and catch the ball and create an interception. Does that make sense?
Yes.
All right, so the intercept on this would be us throwing the ball in a direct line, but it's crossing over the y-axis, and that is the intercept. Whatever our line crosses the y-axis is the intercept.
Okay.
Does that make sense?
Yes.
All right, so what did I just tell you? What is the intercept?
Okay. So the intercept is like when the y crosses.
Crosses what?
Yeah.
Crosses what?
Right.
So the intercept is when you draw your line. It is where your line crosses or intercepts the y-axis. That is the y-intercept.
Based on the points that you've plotted on the coordinate plane. Okay, so now let me ask you this. You said you had a question about the linear equation, y equals mx plus b. What was your question about that?
I just needed help, the process through it.
Okay, so we're going to use the same numbers that you gave us?
You said find two. Can you say that again?
I said we're going to go ahead and just use the same numbers that you gave us, okay?
Okay.
Okay, so I'm going to put y equals mx plus b. We're going to always start with that formula. All right, so if we're given the slope, which we are, I'm going to go to 1x.
Okay.
Let's do. I won't use 1, I'll use 2. 2x plus 7. Y equals
I didn't learn it that way. I didn't learn it that way. Ooh.
Okay, so
that?
I use the 2 from the function table, and I use the 7 from the function table. Okay?
Oh, okay.
Okay. So
yeah. Oh, are you? No, I mean I have to plug in M and B. Like there's a process to do M and B.
Okay, so M in this equation, y equals mx plus b. Your x-axis represents your M. And your b is represented by the points you have over here in your y-axis. So you're saying y equals 2, which is your x, or 2x plus your y, which is 7.
Okay.
And then you're going to solve for y. And you don't really need to solve for y, because if you put your finger over this right here, it tells you that your y is going to be a positive 7.
I found M a different way where you have to do y2 and y1 and M2.
Yes.
I mean x2 and x1.
Yeah, and you're doing a subtraction?
I'm sorry?
Are you doing the subtraction?
Yeah.
Okay, so you're doing y2 minus y1 over y1 over x2 minus x1.
Right.
I know this way too.
And then I have to plug in the numbers. Like I have to find.
But did they give you the points? Did they give you a set of points?
Yeah, and it's any one of the x and y ordered pairs.
Okay, so you can use any of these points to come up with your slope.
I'm sorry?
You can use any of these points. They said you can use any of these points to come up with your slope. So which ones did you choose?
1 and 5 and 2 and 7.
1 and 5 and 2 and 7. Okay.
1, 5, 2, 7. So first, you're just going to identify your x and y values. X is always the first number. Y is always the second number. You with me?
Yes.
Okay. So this is going to be my first y, my first y, and this is going to be my second y. So now I'm going to plug in 7 minus 5.
So Star, what would you plug in for x?
X2.
X2.
Hold on. 7 minus 5.
No, Star, look. Okay. What's x2? What is the number that represents x2?
X2 would be 2.
All right. Good job.
Minus what number?
1.
Okay. Good job. So now 7 minus 5 in our numerator is what?
2.
And 2 minus 1?
1.
Very good. So our answer is
2.
2, which we just said was 2 over here, and our y equals 2x plus 7. We said the x or the slope would be 2.
Oh, this is way faster.
I tried to tell you.
All right, Star, thank you so much for calling, but we're going to go ahead and move on to our next caller, okay?
Okay.
All right, have a good evening, Star. Thank you so much.
And remember, we are on Mondays and Wednesdays, so if you have any more questions, you can call back on Monday. All right.
I think we're ready for our next one.
Okay, who is our next caller?
Hello?
Caller, are you there? Okay, so I think they are coming. We're going to...
Let's go back to our problem that we were working on earlier.
Okay, so
I went to the grocery store.
Yes.
And I wanted to buy
You're looking for the better buy.
Jelly beans? Do you eat jelly beans?
I don't eat jelly beans.
Okay, well.
What about some grapes? I like grapes.
Okay, some grapes. We can go with some grapes. So there was one bag of grapes that was $3.99, $3.99 for 16 ounces. And the other bag of grapes was $2.99 for 12 ounces. So I was trying to figure out which one was a better buy, or which one allowed me to get more for my money.
Yes, more for your money. That means better buy.
That's
more
a better
for your
buy.
money.
Okay, so are we going to try and solve this one now?
Let's take the call.
Okay, so we're going to come back to our problem.
No, I'll hold it over here.
And we're going to talk to Edison from Melwood. Edison from Melwood.
Edison, are you there?
Yeah.
Hi.
I have a math problem. It's proportions.
It's proportions. Great, because that's what we were trying to get through a few minutes ago. So help us out. What do you have going on with proportions today?
It's 43/2.
43/2
equals D.
Wait a minute, hold up.
5.
43 halves? 43 halves?
Huh?
43 halves.
No, I said 43/2 equals D/5.
Okay, Edison, are you watching us on TV?
Yeah.
Okay, so can you look at your TV screen and tell us if this is what your problem looks like?
Oh, it's not under. It's like going like a bottom to the right.
Like that?
Yeah.
Okay. That's the same.
But it's like a little. It's like flat.
Okay, it's the same. They are saying the same thing. Okay.
Okay, so Edison, what is this number? What is this fraction?
If division.
Okay, it's 43 halves.
Oh.
Okay, because the 2 is at the bottom or the denominator. The 2 is the denominator that's representing halves.
Oh.
Oh, yes, halves. Got it?
Yes.
All right.
So what is your question?
I'm trying to find the missing proportion.
Okay, you're trying to find the missing proportion. And Edison, what do you think we should do?
I think you first divide 43 into 2.
And why do you think we should divide 43 into 2?
I'm not sure, but I think that's how you do it.
Nope.
Do you have any notes from your class?
I didn't bring it.
You didn't bring any notes from your class. Okay.
Okay, so no, we're not going to be doing any dividing. Okay? We're not.
No.
We're not going to do any dividing. What I suggest we do is cross multiply. I'm sure Miss McCants.
I think you crisscross.
That's right. You're going to cross multiply. You're going to go like this and go like this.
Yeah, and then you do the other one. Yeah.
That's right. Edison, I knew you knew what was going on. Okay? So now if I have 43 and I'm multiplying it by 5, what do you think is going to happen?
You multiply, right?
That's right.
So what's 43 times 5?
I need to write it down.
Okay, you're going to write it down?
Can we talk you through it just to save a little bit of time? What's 3 times 5?
3 times 5 is 15.
Okay, so we're going to put the 5 in the ones place, and then we're going to carry that 1 over to the tens place, and we're going to multiply 5 times 40. What's 5 times 40?
Oh, 40. You're right. I'm sorry. My bad.
4, you mean?
Well, this is really 40 because it's in the tens place. So what's 5 times 40?
5 times 40.
What's
200?
Oh, all right. Very nice job. And then we're going to add that little 1 right there. And what is that?
1.
Okay, so 200. Well, that's actually 10. I'm sorry.
201.
We're going to add 10. So that would be what? 200 plus 10.
200 plus 210?
Very good job. So 43 times 5 is 215.
Oh.
Okay?
Okay.
And what's 2 times a variable? It's just going to be 2 times that variable, 2D.
Edison, do you know what the variable is?
I can't remember what the variable.
Okay, so in this problem, the variable is represented by a letter. What letter do you see in this problem?
A D.
Very good job. So that variable in this problem is D. What if I had a Y here, Edison? What would the variable be?
Huh?
If this was a Y instead of a D, what would the variable be?
What do you... Well, you do the same thing, right?
Right. So remember, a variable is a letter that's written in our math problems, okay?
Yeah.
Okay. So now we have 215 equals 2D.
So what we're going to do is we're going to do the inverse operation of multiplication, which is division.
Oh my goodness. Did you catch that, Edison?
Yeah.
Okay.
Okay, inverse operation of multiplication is division, which means inverse means opposite. So we're going to divide both sides, because whatever I do to one side, I have to do to the other side. We have to keep it even and equal because of that equal sign.
215 first?
Okay, wait a minute, Edison. Did you understand that? Whatever you do to one side of
the other side.
Okay, all right, we got that. So let's start over here. We have 2D divided by 2. What's going to be left on this side?
How do you divide a D?
Oh, can you divide a D?
No.
No, but can we divide 2 divided by 2?
Yeah, it's 4.
If I have to and I divide it into 2 groups.
Hello?
If we have 2 and we put them into 2 groups, how much is that?
What, you divide it?
Yes, I have 2 groups and I'm putting 2 in each group. What do I have?
Oh, 0.
Edison, look at the picture.
Okay.
Okay, and I'm going to put. So how many would be in each group?
1.
There you go. So if I have 2 divided by 2 is what?
2 divided by 2 is 1.
Very good job. And then I have that letter D right there that can't really go anywhere, right?
Yeah.
Okay, so now I have to do 215 divided by 2. Whew. What do you think we should do?
You said, 215 divided by 2?
Yes.
You divide it.
Okay. So how many times? Go ahead.
2 divided by.
So we're going to start with the 2. How many groups of 2 are in 2? Or 2 times what number equals 2?
1.
All right. So we put the 1. We're going to subtract, and then we have 0.
And then you subtract it. I think you bring a number down.
There you go. We're going to bring down the 1. Now, can we say 2 times some number gives us 1?
Well, then equal the same number.
Well, 2 times what would be 1, Edison?
2 times what?
Can we do that?
No.
No. So we're going to put a 0 up here. What's 0 times 2?
It's 0.
Very good job. We're going to subtract. We have 1, and we're going to bring down the 5. So 2 times what number gives us 15?
2 times...
Or gets us closest to 15 without going over?
I don't know, but let me see.
I'm pointing at it, Edison.
7.
Yes.
Very nice job. What's 2 times 7?
2 times 7? 2 times 7 is 14.
2 times 7 is 14. And then I'm going to subtract, and I have 1 left over. So my answer is 107 with the remainder of 1/2.
Okay.
Or 5/10.
Okay, Edison?
Okay.
All right. Thank you so much for calling in. I'm sure your teacher will be so pleased and proud of you for calling us tonight, okay?
And
all right, so our show is just about over.
Your name went into the treasure chest.
Oh, yes, Edison's name went in. So we're going to go ahead and draw a name out tonight.
Okay, yes. Let me close my eyes.
Let's see who's going to win our prize.
Oh, wait a minute. That one didn't feel right. Let me just...
And our winner is Sanaya from Glen Arden Woods. Glen Arden Woods. All right, so we had a great show tonight. Thank you to everyone who called.
That's right. And remember that you can always
count on us.